All right, in this video, I'm going to talk through how to approximate the square root of 99.4 using differentials. The key here is that we know that the square root of 100 is 10. So the square root of 99.4, since 99.4 is just a little bit less than 100, should be 10 minus a little chunk. So differentials helps us approximate, not get it exactly, but approximate it, and approximates it really well, how much we go down from 10. So the key here is that we know y equals root 100 would give me 10. So I am working with the function y equals the square root of x, and I want to know how much does, I'll write it out, hold on. I want to know how much does y change if I change x by negative 0.06. Again, I got y equals root x. I know that if x is 100, that we get 10 for y. So I want to know how much does y change if I change my input x by negative 0.6. So again, we're working with, and I'm going to write all the little pieces that we're going to use here. Y equals root x. I know if x is 100, that y is equal to 10. So with a delta x of negative 0.6, comma, what is the delta y that goes with that? So how much do I add or subtract to the 10? So once I get all these pieces, x equals 100, y equals 10, I'll highlight all these, this, and this, then I can go and calculate my delta y. So I'll do it in blue. So what I do is we start with our function y equals root x. I find the differential, dy is equal to 1 over 2 root x times dx. From there, I'm going to move over to an approximation. So, because the dy is an instantaneously small change in y, same with the dx. So, if I take a larger chunk, it is a change in y. And then that's approximately 1 over 2 root x times some change in x. So, if you take a look here, I'll highlight here. This is what I'm looking for right here. That's this. I know, hold on, I'm just going to highlight like this. I know delta x is equal to 0.06, so that's going to go in here. And I know that my x value is, use this right here. I know that my x value is 100, so that's going to go in here. So when I go ahead and calculate that, I get that my delta y, which is what I'm looking for, that's going to fill in right here, is approximately 1 over 2 root, and I take the x value for which I know the function, so in this case it's 100, and then times the change in x to get from the 100 down to the value that I'm looking at. So that's my negative 0.06, so times negative 0.6. And then from there, I just calculate this. So this simplifies to, I have a 20 in the bottom, and then I'm going to just write my negative 0.6 in the top. And then to simplify this without a calculator, what I'm going to do is take this decimal and move it once, take the same decimal here, move it the same direction, which gives me a negative 6 divided by 200, and then both those numbers are divisible by 2, so I get negative 3 over 100, and then that can be converted to a decimal, which is negative 0.03. So this tells me how much the y changes from here to here. So that negative 0.03 is, I have plus a negative 0.03. And then this is an approximation. So maybe I'll write this over here. So I got root 99.4 is approximately root 100 minus or plus my delta y, which is equal to 10 minus 0.03, which gives me 9.97. So that's our answer in terms of like how we approximate it, right? Boom, we get 9.97. Now, to show you how accurate this is, if you were to plug this into your calculator, plug the square root into your calculator, you would actually get 9.96995. So these two numbers are very, very close to each other. So if we can't use a calculator, or if we need to approximate something in one way or another, we can use these differentials and we can get really accurate, close answers. So you're going to write this for your answer. And hopefully this makes sense a little bit of like why we do what we do and how it connects it to the root function and all these deltas and everything like that. So thank you. See ya.